Good day everyone. Integration part 14. In this, I told you already, it will be an identification part. That is, I will give many mixed sums and I will help you how to identify them, as to which method you have to adopt and integrate. Before going into that, let me give a quick recap of what you have learned in the 13 parts. I can't say in detail, just a quick recap, okay? So, first is straight formula applications. Then the next is substitution method. Substitution is a method in itself and you will also use it in the other methods of integration. Then trigonometry means if you have a product, you should express it as a sum and difference. If it is some power, that is like sine squared, sine cube, like that, you should express it as multiple angles and then you have to integrate. Then you have learned completing the square method. You have learned expressing the numerator as a into d by dx of the quadratic plus b. Of course, I have told you in which cases, in which type of sums you have to use all these concepts. Then you learned partial fractions. In that, many methods. Then integration by parts. Then certain general concepts like adding and subtracting, and sometimes expressing the one in the numerator as sin squared x plus cos squared x, and some special models like integral dx by a plus b sin squared x, a plus b cos squared x, a sin squared x plus b cos squared x, like that. Then you learnt integral e power x into f of x plus f dash of x dx, that type. Like this you have learnt many methods. So, before coming into this part 14, you should first be thorough with all the methods we have done in the 13 parts, and then if you approach this, definitely it will be easy. What you do is, see, first to start with I have taken 6 sums. So, you have to copy these 6 sums and you have to identify yourself. Otherwise, you can listen to what method I have told you, okay? So, like that you proceed. Then I will take another set of sums. Now, let us see. The first sum is integral 1 by root 3x plus 4 minus root 3x minus 1. Whenever you have like two linears, root linears, with either a plus sign or a minus sign, immediately you should think of conjugation, okay? It is either you can conjugate or you call it as rationalizing the denominator. When you do that, this denominator will be just a constant and the numerator you will get 2 roots and you can easily integrate it. Come to the second one. You have got x power 5 by x plus 1 dx. When you look at this numerator and denominator, you should think the degree of the numerator is greater than that of the denominator. So now you remember what concept? You have to first divide. You do long division. Divide the numerator by the denominator till your remainder is at least 1 degree less than the denominator. Then express it as quotient plus remainder by divisor and proceed. Okay? Come to the next one. Integral 5x plus 3 by root x squared plus 4x plus 10 dx. What is the numerator? It is a linear. The denominator is a root quadratic. Immediately the concept is the numerator is equal to a into differentiation of that quadratic, that is you will get 2x plus 4 plus b. Then you will equate the coefficients and you will get the values of a and b and then split it into 2 integrals, and one integral will be substitution, the other one will be completing the square method. Okay? Look at the fourth sum. You have got an algebraic function, you have got a logarithmic function. Immediately you should identify it as integration by parts. So use the highlight rule to identify your u function. L comes before a. So this will be your u function and that will be your dv function, right? Come to the fifth one. Integral 1 by 4 cos squared x plus 9 dx. Remember the some special formula I taught you? It is like a plus b cos squared x. So Divide the numerator and the denominator by cos squared x, that is step 1. Then put tan x is equal to t. That's all. Actually here you will get some secant squared x. You can write it as 1 plus cos tan squared x. Okay. Come to the sixth sum. This is one pattern. If you get 1 by 1x and some x power n plus or minus 1 like that, then you know you have to multiply the numerator and denominator by x power n minus 1, right? The numerator and the denominator multiply by x power n minus 1. Then you substitute x power n as t. Here it is 6. So you will multiply by x power 5, both the numerator and denominator. Then substitute x power 6 as t. So the first 6 sums are a bit easier. You can easily identify. Shall we go to the next set of sums? 7th sum. Integral 1 by sin squared x cos squared x dx. You cannot immediately identify it, right? Now, here you can see a product of sin squared and cos squared. In the numerator, you are having 1. So, you can write the numerator as sin squared x plus cos squared x by sin squared x cos squared x dx. Now, you split it into two integrals. In the first part, sin squared x will get cut. In the second part, cos squared x will get cut. Then you will easily integrate. Okay? Now, 8th one. Integral e power x into 1 minus sin x by 1 minus cos x dx. On seeing the e power x multiplied by something, you can guess it is going to be some formula related, that is e power x into f of x plus f dash of x dx, right? But it is not a straight, you cannot fix something to f of x and something to f dash of x. So here, you have to use some half-angle formula. That is that sin x, you have to write it as 2 sin x by 2 cos x by 2. The denominator 1 minus cos x, you write it as 2 sin squared x by 2. Then you split it, no? 1 by 1 minus cos x minus sin x by 1 minus cos x, and apply this half-angle formula, and then you will be getting that f of x, f dash of x there, and e power x will be there. So you can use that formula. Okay? Then the 9th one. Integral 2 sin 2 theta minus cos theta by 6 minus cos squared theta minus 4 sin theta. Here also nothing straight, right? So first what we can do, that sin 2 theta I can write it as 2 sin theta cos theta, isn't it? Then I can write that as 2 sin theta cos theta minus cos theta, 6 minus this cos squared theta, I will write 1 minus sin squared theta, 4 sin theta. Okay? Now in the numerator you can take 1 cos theta common. So you will be getting 4 sin theta minus 1. The denominator you are having sin squared, sin and some constant at all. So now you can substitute sin theta is equal to some t, so that cos theta d theta will become dt, and then you can use partial fraction and then you can solve this sum. Okay? Then let us come to the 10th one. You are having an x squared in the numerator, and here one quadratic, here one quadratic, everywhere you get that x squared. This is one special type. So you have to only take the algebra part. Don't consider the integral or dx. In that you make a substitution x squared is equal to t. You need not do dx and all. Now actually the algebra part will become t by t plus 4 into t plus 9. Use the partial fraction method and get it as a sum of two things, a sum or difference, whatever. Then immediately replace the t by x squared, and then you have to do the integration only in terms of x and not with respect to the variable t. Remember, that's very important. Okay? Coming to the 11th. if you see the denominator, it can be factorized. So you can keep that 1 plus x as it is. In the third and fourth term, you can take x squared common. So you will be getting 1 plus x. So you will get 1 plus x into 1 plus x squared. So now this is a partial fraction sum. So you can write a by 1 plus x plus bx plus c by 1 plus x squared and then proceed. So sometimes straight away it may not look like a partial fraction sum, but once you factorize, then you get it like that. So hope you follow these sums. You have to do it fully and then only it will be clear to you. Okay. Now let us see this set of sums. A bit higher grade I can say. Okay. So we are coming as per the gradation only. Now integral 1 by root 3 sin x plus cos x. When you see this root 3 and here actually the coefficient is 1, immediately you should think that root 3 by 2 and 1 by 2 we can express in terms of sin or cos, isn't it? So now what I can do is, I am going to multiply and divide the denominator by 2. That is, I will write integral 1 by root 3 by 2 sin x plus 1 by 2 cos x. Okay. To compensate, there will be 1, 2 here and then dx. So now this 1 by 2 I can take outside. So I will get 1 by 2. This root 3 by 2 I can write as sin pi by 3. Okay. Then this is sin x. That half will be cos pi by 3 cos x. Now you see it is like cos A cos B plus sin A sin B, which is cos of A minus B formula. It is better you bring it in terms of cos. Okay. You can take it as sin also, then the answer will be a bit different, but that doesn't matter. So you will get 1 by 2, I will get 1 by cos of x minus pi by 3 dx. Take it to the numerator, you will get it as secant and then apply the formula. So generally when you get like root 3 like this, or sometimes just a sin x plus cos x, then divide by root 2. So 1 by root 2, 1 by root 2, you can express it in terms of pi by 4. So this type of sums or some special sum. Then let us go to the next sum. Okay, that is root secant x minus 1 dx. Now you can write root secant x as 1 by cos x minus 1 dx. Okay. So if you take LCM, you will get 1 minus cos x by cos x. In the root itself you conjugate into 1 plus cos x into 1 plus cos x dx. Now I will get 1 minus cos squared x in the numerator, which is sin squared x. So 1 sin x I will get in the numerator outside the square root. Here I will get cos x into 1 plus cos x dx. Now you substitute cos x is equal to t. So the numerator will become minus dt. Then you can apply completing the square method for the denominator. Okay, is this sum clear to you? Then let me move on to sum number 14. That is integral sin inverse 6x by 1 plus 9x squared dx. I can write that as sin inverse 2 into 3x by 1 plus 3x the whole squared dx. Does it look like 2 tan theta by 1 plus tan squared theta? You know sin inverse 2 tan theta by 1 plus tan squared theta is sin 2 theta, isn't it? Sin inverse of sin 2 theta. So now I am going to write 3x is equal to some t or theta whatever. 3x is tan t. So when I differentiate, I will be getting 3 dx that is equal to secant squared t dt, or dx will be secant squared t dt by 3. Now if you go there, you will be getting this part will become sine inverse sine 2t, right? Because you are going to get that 2 tan theta by 1 plus tan square theta, which is sine 2 theta. Then here for the dx you will be getting 1 by 3 secant squared t dt. So this part will become now 2t. So take 2 by 3 outside, you will be getting t secant squared t dt. Apply integration by parts, and finally for t you have to substitute in terms of x. Is it clear? You do it fully, then only you will understand. Now let us go to the last sum, that is the 15th one, that is integral 1 minus sin x by sin x into 1 plus sin x. If you look at the numerator, you have 1 minus sin x. Here I have 1 plus sin x. I want to get some 1 plus sin x so that it will be a bit easy. So I am going to add and subtract sin x to the numerator. So now the numerator will be 1 plus sin x and minus sin x here. The denominator I will write as it is. Okay. Now I will group that 1 plus sin x. Then I will write minus 2 sin x by sin x into 1 plus sin x dx. Now split it into two integrals. In one part this term will get cut, in another part this will get cut, and then you can proceed. So hope that you now get some idea about how to identify the sums. Like that you have to choose sums from some question paper which are in generally big, no? And you should try to identify and learn them. So do all these sums, and if you have any doubt, I have already told you, you can always contact me in my number 98414245159, okay, or any other doubts 98414245159. If you contact me in WhatsApp, surely I will clear your doubts. I will reply to whatever questions you give. Any other sums which you need also, I will help you. So now the indefinite integrals is coming to an end with this part 14. So we have to start now definite integrals. But first become thorough with indefinite integrals. Then the definite integrals will become easy for you. Thanks for watching the video. Share it with your friends and classmates. Thank you once again.